Hi, everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human Centric AI podcast, where each episode we feature thought leaders doing cutting edge work in the AI space. A little about us: SmartEye is the global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments, bridging the gap between humans and machines for a safe and sustainable future. Today's episode features Carl Serkenthaler and Simon Schweerd, both from the Institute of Flight Systems. Carl studied biomedical engineering and received his Master of Science degree in 2018. Afterward, he worked as a research engineer in the field of numerical modeling and has been working as a research associate and PhD student at the Institute of Flight Systems since October 2020. His research objective is pilot activity recognition using probabilistic graphical models based on real-time data, eye tracking, and psychophysiological sensors. Simon studied engineering at the Technical University of Munich with a bachelor's degree and master's degree in mechanical engineering. At the Institute of Flight Systems, he developed future cockpit concepts for military aircrafts and is pursuing his PhD in the estimation of situation awareness based on pilot monitoring via eye tracking. His general research interests include operator and pilot assistance, adaptive automation, and human automation integration. Simon, Carl, and I talked all about their work with eye tracking in aviation, including cooperative automation and human automation interaction in aircraft cockpits. Let's listen in to learn more. Okay. Hi, everyone. Thanks for tuning in. With me today, I have Carl Schürchenthaler and Simon Schweerd of Institute of Flight Systems, Aircraft Dynamics, and Flight Guidance. Simon and Carl, thank you so much, both of you, for speaking with me today.
Hi, happy to be here.
Hi.
Awesome.
Yeah, me too.
Great. So to start, please tell us about your background. What is your role at the Institute of Flight Systems today?
Yeah, sure. So my background is mechanical engineering, but I'm a researcher for 6 years at the Institute of Flight Systems now. So the institute is part of the University of the Bundeswehr, that is the Federal Armed Forces of Germany. And at the institute, we try to develop technology for new cockpit concepts for both military and civil aircrafts. And my focus have been on adaptive assistance, which is assistance systems that take into account the mental state of the pilot, that try to adapt to the mental state. And my research in the last years was about estimation of situation awareness, and which was mainly based on eye tracking systems. And yeah, also with me in my lab is working Carl.
Hello, everyone. Thanks, Simon. So my background is biomedical engineering. I studied that in Regensburg, and I previously worked in the fields of numerical modeling. And now I'm happy to say that I work for 2.5 years now at the Bundeswehr for modeling activity recognition to actually see what the pilot does in a real-time system. And as Simon already mentioned, we build simulators to prove our concepts. We work on our daily basis. And myself, I work also with SmartEye on a daily basis, but also physiological sensors, for example, for activity inference.
Awesome. And I know a while back you had sent us some stuff on the Humix lab. Can you talk about what that is? How does that work? What is it trying to do? Why?
Well, in the Humix lab, we try to pool all our resources for mission technologies. So mission technologies is any technology you could use in a military or civil mission. And Carl and I, we work in virtual simulation, which is kind of in the middle between constructive and live parts of the whole development tool chain. And the Humix lab tries to bring those activities at our university and from our institute together to be like more of a center of competence in that area.
All right. So for context, can you share a little bit more about how you came to work with SmartEye? So I understand you use SmartEye and iMotions almost extensively, as it is good for your use case. So maybe you can share more about your use case and on how that collaboration developed.
Yeah. So we use eye tracking, or have been using eye tracking for I think about like 15 years at the institute. So maybe for my career here. And I think the requirements are pretty the same as for everybody else. So we need as accurate and as precise measurements of the gaze as possible. And also, I think, which is important for us because we are doing like flight simulations, so we have a pilot, it must be robust against rotations of the head and movements of the body. And we also want to cover like a big field of view. So for a pilot, you have your outside window, but you also have your cockpit systems. And with Smarter, we can model that, and we can have like multi-camera systems which cover the whole area. And I think another requirement might be that we use the system in closed loop applications. So not only for analytical purposes after simulation, but during operation, we need to access measurements. And that's when we need like a near real-time interface to software. And Smart Eye also provides that. I think it's the same for iMotions, right, Carl?
Yeah. In addition to Smarter, we also use iMotions for acquiring physiological data. And as Simon already pointed out, we need a great API on the side of Smart Eye and also for iMotions. And both of these softwares actually provide that in order to acquire this time synchronized data. And we then later synchronize it to our mission stuff happening, for example. So you are able to acquire ECG data. We use also EDA data, so skin resistance, apneas, respiration, and all different measures what we use actually to find metrics to evaluate the mental state of the pilot.
Cool. So based on your expertise and your research, what are some of the problems with human automation interaction that you have identified?
Well, I think like the negative effects of automation, they are like a big topic in aviation, at least since the 80s. And I think like the automotive domain is currently discovering similar phenomena. And you have things that are like terminologies like complacency, automation bias, or loss of situation awareness. But I think the basic problem is that when you introduce automation into controlling a system, it takes over some functions that have been formerly done by the operator, which is nice and which takes away some workload, and which works also very good when the automation is like reliable. So there is no need for any intervention by the operator, so you don't have any problems in the interaction, I think. It becomes problematic when the automation is not 100% reliable, or it does some kind of security-related functions, or it does manipulate some kind of the system state which becomes relevant in another task domain. So when the pilot has to, or the driver, it's the same thing actually, when he has to take over the task because he has to intervene something because the automation does not work, probably it becomes problematic. So maybe you know the same thing from everyday life with navigation systems. I, for my part, completely lose track of where I am when I'm driving with a navigation system. And when, for some reason, it doesn't work anymore, I quickly get overloaded by like the task to orient or to make a decision. And it's the same thing with more complex task environments.
Yeah, absolutely. So in contrast to this everyday life example, when you look in a fighter cockpit and you really observe what the pilot is actually doing, it's really incredible. So how they like perform in these missions is incredible to watch, because the pilots have to keep up the situation awareness all the time, up to date. It is their behavior depends heavily on rapid decision making, which also involves fast acting. You have to act. Your act also depends on ethical decisions you have to make. You have to collaborate with someone. You have to communicate all the time, and that's a heavy use case actually for our research.
Mm-hmm. So talk to me about cooperative automation. What are some of the traits of it and your ideas around adaptation strategy?
Right. So when we think about this problem with human automation interaction, we want to have like a way to solve it. And one way to maybe could solve it is to have like kind of a cooperative automation. This is like inspired by human cooperation. When you think about a civil aircraft cockpit with two pilots, the co-pilot is continuously monitoring not only the system state, but also he's also monitoring his pilot.
Right.
So he knows what he does, he knows what the tasks are, he knows where the attention of his pilot is, and what the task load in general is, and so on. And the co-pilot supports based on these factors. So it might be a way or a good way to design a cooperative system or a cooperative automation that mimics these kind of behaviors. And one central factor for that is that you understand, well, the mental state and things like attention or workload or situation awareness. These are like models of the mental state. So you have to have some kind of estimation, software-based estimation to be able to adapt to those things, to implement and mimic human cooperation.
So some of the work you shared with me involved a visualization of adaptation to the cognitive state, and the goal was performance increase. So because this is audio only, can you talk us through that process flow, how it works, etc.?
So yeah, basically the idea is, as someone heard, for example, this is, well, we use tools of psychology, right? So when we talk about mental states, these are in the field of psychology. But we as engineers, we tend to see the problem sometimes as an engineering problem. So imagine you have like a human interacting with a computer or with automation, for example. You have as input tasks, and these tasks, the pilot has to react to them and has to, well, to execute them. And as an output, you get a task execution. And we as engineers, we see this as a control circuit, and we can measure actually this control circuit and apply a performance measurement on it. And well, if the performance is high, it's good. If the performance is low or in like a medium state, it could be enhanced, right? And in the end, our goal of adaptive persistence is to increase the performance of the pilot. So the question arises, how actually can someone like measure this task and task execution output? It is known from research that mental states or the mental states depend on mental constructs, right? So like Simon pointed out, situation awareness, for example, or attention, or everybody knows workload, right? If you have too much to do, your workload is high. And from research, we know that there are dependent variables we can actually measure, and these correlate with these mental states. For example, if I have a high workload, well, you could measure my heart rate, for example. If this is in a high state, for example, this indicates that I'm in a high mental workload situation right now. And this is what we do. So we use smart eye or our emotions to acquire gaze or physiological data to measure these dependent variables. And then we can use metrics, for example, in pilot observations to estimate the mental state of the pilot. And two major outputs we can acquire from this. One, on the one hand, we can derive the task context of the pilot. For example, if I measure with gaze, I can measure what objects the pilot perceives and can derive from that. These are the targets the pilot is dealing with. And also these are the tasks correlated with these objects. Also, if I know from this task context on the other hand, what the activity of the pilot is, someone could derive the mental state of the pilot. For example, the activity, like a strike task, for example, could be a high mental workload demanding task, and someone could derive the workload from this task. Mm-hmm. And an agent has to, respect these two aspects, and also has to know what has to be done in this mission, for example. And then we have a three-stage process here. So we have a pilot plan, what has to be done actually in the mission. We have the task context, so this indicates what the pilot is actually doing. And the mental states indicate, is there actually a demand on assistance? And all these three stages form the basis for adaptation policy. And dependent on these 3 stages, we can like create an intervention policy, for example, and to apply a strategy to actually assist the pilot. For example, in the high mental workload situation, for example, the agent can decide, I actually help the whole team with giving this task to another pilot because a side task is not processed correctly, for example. And then the agent actually, what we have at the first stage, the tasks domain. Well, the agent can really like adapt this task in order to increase the performance. And our goal is actually to develop adaptive assistance and to measure a performance increase. That would be great. So this is our duty in this research.
Awesome. Fascinating. And next, I wanted to talk about human adaptive systems in aircraft cockpits. So aviation is definitely a frequent use case for Smart Eye customers. Can you talk us through the work you've done there with regard to, observation and estimation of human models?
Yeah, so we have actually a lot of publications on that. For example, we have developed some systems on a transport helicopter. Also, we successfully implemented, in this case, adaptive assistance in these helicopter simulators. We also did research on fighter jets in like a single fighter or a dual fighter and a whole Cameo. So 2 fighters performing in one virtual environment. And we actually measured a performance increase at some point. So it is really hard to actually define if this works in the end or not, because it depends on so much variables, like the acceptance of the pilot, for example.
Right.
Yeah.
Yeah, you can you can measure it on different levels. I think so. It's a hard problem. The whole thing Carl talked us through. It's a hard problem because when you have some kind of unreliable pilot mental state estimation and you make wrong interventions, pilots get frustrated by it. So in most studies that we did, we can see some kind of performance increase in several or in very specific task situations. Maybe because the experiment was designed like it, maybe because the adaptive strategy works really well for a particular task. But it is really hard to get like an overall adaptive system, like the one adaptation policy or adaptation strategy we have not found out yet. This problem is not solved. That's why we're still working on it. So the accomplishments, I think, were like we closed the loop. So this is pretty hard when you have like a mental state estimation to have it like in real time and to do something useful with it. But we also have, we encountered a lot of challenges. So, like I said, when the estimation is not reliable, pilots get frustrated. Pilots are not used to working with adaptive systems. They are relying on determinism and predictable system behavior. But when the system monitors you, it kind of gets undeterministic from your point of view. So, for example, it tells you something that you don't know, well, you cannot anticipate this. And this pilots also have to, in my opinion, have to train with adaptive systems, have to like have a good mental model of what the monitoring is doing with them, or what is the system monitoring, to raise the acceptance. So this is, I think like a typical problem for us. Pilots don't like adaptivity, but even if it works well, this is interesting. So you have to work on the usability, but also on the training.
Yeah, we had like tests, and I think that in a automation term, I would use an automation term, trust. The trust was low actually. So if they are not trained and they are not used to adaptive assistance or adaptive systems, they don't understand how it works. So, and this builds up mistrust, right? So for example, in your car example, like you missed a route or to like turn right because the system knows you have to go right actually, and then intervenes. It's weird, right?
It's just like my father-in-law who still distrusts the navigation system because it failed 10 years ago or something like that.
Yeah, so and I wanted to ask also, and I think you're maybe starting to go there, but based on your work, what do you believe is the future of maybe eye tracking in the aviation industry?
So in my opinion, there are three applications.
Yeah.
First of all, you have and those applications are not same difficulty, I would say. So first of all, you could use eye tracking in training. So that's a thing we get a lot from customers, that you could integrate the system into training simulators and get like an objective view on pilot performance, especially on pilot monitoring performance. So you could measure objectively how well is the pilot monitoring his system, and that could inform, I don't know, a supervisor or kind of a teacher how to proceed with this training. A second use case I think I can think of is use it in, if you really could integrate it in like a real cockpit. You obviously could do it, but if they were doing it, you could use it as an input for black box data collection.
Yep.
So which could help in accident analysis on the one hand, but also on the other hand in just human factors analysis. So when you could collect that data, you could answer a lot of questions about pilot behavior just by using this data that you get from those cockpits. And the third application is like our research focus, the adaptive systems. They are, I think, harder to get into the cockpit because they are really manipulating something in the cockpit, which is from a security safety perspective more challenging, but it could enable some things like single pilot operations. So you have when you monitor the only one pilot in a civil aircraft, you could, I don't know, detect some kind of error, or also when he's incapacitated or something like that, and turn off higher levels of automation. So this might be an enabler for that. And I think this is like the three main applications for eye tracking.
Yeah, you're
Any other
absolutely
idea?
right. I think training is a so yeah. Regarding to that training, I think that there's a lot of potential in training using eye tracking. Yeah.
Absolutely. Hopefully building up that trust element, as you mentioned earlier.
Yeah,
Right.
absolutely. Well, it's AI, from ChatGPT 3, for example.
Yeah.
We have to really understand how it works and to build up a workflow with these stuff, right?
Yeah.
So, well, the people have to deal with automation in the future.
Mhm. Absolutely. All right. So last question for our listeners. Can you let them know where they can go to learn more, or do you have any other call to action for them?
Yes, so like every research facility, I have to mention, we have publications like on different aspects of the aviation, like transport helicopters, military combat helicopters, jet simulators, also civil aviation. We have currently a project on that, kinetosis, one project we have to mention here. And we also are present on LinkedIn. Everybody's welcome to to visit our site and if someone from industry or other research institutions, we are open for any cooperation. So just like send us a mail. You can look up the staff online. You can like send us a mail or like text us on LinkedIn, for example.
Mm-hmm.
And also students who like might listen to this. We are looking for students all the time on different topics like mission planning, pilot observation, assistance, for example. And our concepts, I would say, adaptive assistance, I think like Simon would say the same. Of course, they are adaptable to other fields of industry, right? Like automobile, for example, like in your car. I could imagine these concepts in a car, maybe in a different idea or different like concept, for example, but to adapt this in automobile, also civil aviation. I think everywhere where automation is involved, our concepts could be a part of it, right?
Yeah, absolutely. Anything else, Simon, you would add?
No, that was a good summary of people who could contact us. So we're open to any type of
absolutely.
cooperation. Yeah.
Awesome. All right. Well, that That is all I have for you,
Okay.
Simon and Carl. It was such a pleasure speaking with you. And thanks again so much for making the time to speak with me today.
Yeah, it was great. Thank
Thanks,
you for
Ashley.
having us.
It was such a pleasure speaking with these two brilliant researchers on their work in understanding the relationship between human and machine interaction and automation, and essentially building trust between pilots and the systems embedded in the aircrafts that they operate. It's always exciting to listen to the work people like Simon and Carl are doing to help make the next strides in aviation technology. I hope you enjoyed today's episode. Don't forget to subscribe to the Human Centric AI podcast on iTunes, Google Play, Stitcher, or wherever you get your podcasts for new episodes. We are also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag Human Centric AI podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.